So in our notes, we learned that ionic compounds will conduct electricity, but only when they have been dissolved in water or are in their molten form, meaning they have been melted. All right. So what I have here is we're going to do a little demo to show this. Okay. So what I have here is some sodium chloride table salt. This is what you put on your food when you salt your food. And you can see it is in the solid form. So here we have a light bulb, all right, hooked up to some electricity, all right? And when I put it into the solid salt, what happens? Nothing. Remember, solid salt does not conduct electricity. Now, I'm going to prove to you here, I have some water, okay? And now this is distilled water. All right, and distilled water is what we call fancy water. So what this means is it has had all of the impurities removed from it. So think about where water comes from. It comes from the ground. And so when water comes out of the tap, there's some ions and minerals in there. We also put chlorine in water to make it safe to drink. So distilled water is pure water where all that's been removed. Distilled water also does not conduct electricity. All right, so you can see right here, I put my light bulb into the distilled water. Again, nothing happened. All right, Miss Colson, then why is it not safe for me to swim when there's a thunderstorm? Well, there's a lot of reasons for that. But remember, the water you're swimming in is not distilled. It will conduct electricity. All right, so let's make some non-distilled water, like what you're swimming in. If I take some sodium chloride, whoops, ooh, I dumped a little too much. But that's okay. I just have to do a little bit more stirring. Okay, so when I put my sodium chloride, now what kind of change is this? Is this a physical or a chemical change? Think back to Unit 2. Dissolving. Is this physical or chemical? The salt is still here. The water is still here. So it is physical. Good job. If you said physical, good job. So what happens when I put my light bulb in here? Check that out, friends. The light bulb turns on. So a perfect example, salt in its solid form did not conduct electricity. But when I put it in here, we did conduct electricity. Now, what if I dilute my sample, okay? So I dilute my sample. Let me see if I can get it diluted enough. All right, so what I've done here is I've diluted my sample. So I've got more water added and less salt. That light bulb is still pretty bright. All right, so that light bulb was still pretty bright. So let's keep diluting it, all right? And let's see what happens. Oh, there we go. It may be hard to see on the video, but it is definitely significantly less bright. All right, so it is definitely significantly less bright. All right, so I used up all of my water and I diluted it one more time. So I used up all my fancy water. There we go. Look at that. So as I continue to dilute it, you can see here that light bulb is definitely less bright. So here's a diluted sample. So what does this tell us about the conducting of electricity? Conducting of electricity is dependent on the concentration of the ions, because this is an ionic compound. So when it breaks up into water, think back, ionic compound, it is made up of ions. So when we put it in water, it is breaking this ionic compound into its individual ions. So if I add more salt and I increase the concentration, what do we expect to happen to the brightness of the bulb? When I diluted that concentration, the brightness decreased. When I increased the concentration, boom, there we go, super bright again. Now, I cannot show you this demo with a molten sodium chloride because remember, sodium chloride is ionic. It has a high melting point. So I am not able to, in my science classroom, melt sodium chloride safely into its molten form so that we could do a demo. So you're just going to have to trust me on that one. But we did get the demo that it does not conduct electricity as a solid, but it does when dissolved in water.